Alright, welcome to our video today. Today we're going to go over circles. Our goals today are to write equations of circles and to graph circles that have certain properties. So we all know what a circle is, but I'm not too sure if you are familiar with the equation or all the vocab that's associated with it. So that's why we're going to be working in our packet today, and we're going to be filling in the blanks just like what we did in class with parabolas on Wednesday. So, the definition. A circle is a set of all points in a plane. I would say on a plane, but in a plane equidistant from a given point. And we call that special point. I'm sure you could guess it. The center. So what that means is that on this circle right here, every point that I'm coloring in with blue right now is all the same distance to the center, which I'm coloring in as red. So they're all the same distance, all those blue points are the same distance away from the red point. So that equidistant part, that's what we call the radius. So the radius is any segment whose endpoints are the center of the circle and a point on the circle. So in our diagram, we have a radius already drawn, but we can draw any other radius we want as long as we start at the center and go to any point on the edge. Start at the center, go to any point on the edge. So these are all the radiuses, the radii, because they all start at the center and go to the edge. So the next section, we're going to be talking about how to get all of the information out of an equation or out of a graph and go in between the two. Graph to equation or equation to a graph. So what we need to know is what our standard form looks like, or what does our equation look like for a circle. I'm going to write it here, but there's a lot more information packed into the last page in our packet, where it actually goes in and lists all that great stuff, kind of like what I've been given to you, all these cheat sheets with all the information packed into it. So what we have for a circle is x minus h quantity squared plus y minus k quantity squared equals r squared, where the center of the circle is h comma k, and the radius is equal to r. So we're going to use all that information to actually start graphing some of our circles. So let me scroll down so we can have these equations and some graphs. So let's see if we can start doing this. The first equation is almost set up for us. We have an x squared. Notice if we put parentheses around it, it looks pretty much just like above here. Here, because there's nothing else in the parenthesis with x, h will be 0. Here, we have y minus 3. If we look above, we have y minus k. So here, k is equal to 3. Now the last thing to do, the information we can pull out, is here we have equals to 49. That does not mean the radius is 49. What we have to do is say h r squared is equal to 49. So that means r is equal to 7. So that means our center will be 0, 3. And then our radius will be 7. So we have to use the big one here. And I do apologize. I'm not too sure if my stylus will actually be detailed enough so you can get a nice circle. But hopefully you could see what I'm trying to do and make a better version of this on your own paper. So first we have to draw the center. So 0, 3 was 0 to the right and then up 3. So we should put a dot right here. Alright, next what we have to do is use the radius. So what I like doing is just going from the center up 7, right 7, down 7, left 7. So up 7 would be 10. To the right 7 would be right at 7. To the left 7 would be right at negative 7. And then down 7, if I started at 3, I would be down at negative 4. So that kind of creates some parts of our circle. Kind of looks like a square right now, but we can kind of fill in the gaps to make it look like a nice, hopefully look like a nice circle. I'm going to be looking for something like the dots or a pretty good circle, so that way I can see the work that you're setting up. Alright, so that's our circle. If we start looking at B, we weren't given such a nicely set up equation. Here we have to rely on what we covered on Wednesday and practice more yesterday with the sub. We have to complete this square here. What we should be looking for is start grouping our variables together. So here I see x and x. So over here I can put x squared plus 6x. And then I can put all my y's. I have y squared I'm sure some of you caught what was happening. Anyways, plus y squared, and then there's no other y's, so then I can just do this negative 7x all the way over here. We're not going to really use the negative 7x until all the way at the end. So, I need to complete the square. I have a fast way of doing this, and notice that we don't have any numbers out in front of x squared or y squared, so we don't have the more complicated version. But we have x squared plus 6x. We take half of 6, which is 3, and square it. So plus 9 minus 9. Next, we have y. But y is already, well, it doesn't have this linear term like we have the 6x. So y goes inside the parenthesis right away. And we still have this minus 7. and all of that equals 0. So we don't like this. What we want just by itself is this right here, because what's in the blue circle is actually going to be equal to x half of 6 was positive 3 squared. But what was left over was that minus 9. So we actually did the plus 9 minus 9 so that we can just use only the plus 9 part. And now we're left behind with this part that we really don't need for the completing the square part. So now we have to figure out what to do with this. I'm going to combine these two numbers. So now I'm going to get x plus 3 squared plus y squared, and then minus 9 minus 7 is minus 16. Alright, so now that I have my completing the squares, everything's kind of combined, I can look up to the top, and I can think to myself, does it look like our equation yet? And I would have to tell myself no, because the negative 16, this minus 16, isn't in the parenthesis with y, and up here, there's nothing else, like, there's nothing right here that minus 16 could be. So I have to move the minus 16 over to the right. So once I do that, I get x plus 3 squared plus y squared equals 16. So now if I'm looking at this, now it looks like it. Now I can figure out the radiuses. So the center of this circle will be at negative 3, because remember, if it's inside the parentheses, it acts goofy. The y value of that center will be 0, and our radius will be equal to 4, because we have to take the square root of 16. So when we start graphing this, just like the example above, first we start at the center, which is at negative 3 and 0. So we can put a dot right there. And then when we start drawing our circle, we can do that up 4 to the right 4, down 4, over 4, like what I did with the green circle above. So I go up 4, to the right 4, down 4, from the center. Remember, we're always doing this from the center, and then starting at the center and going to the left 4. So now that I kind of have my center and the points around it, I can connect those 4 points that I carefully drew and try to draw a circle carefully as well, so that way it looks nice. So that's my circle that would come from the equation B. Our green circle came from the equation in A, and now let's draw a blue circle from the equation in C. If this is making sense to you, please feel free to skip to the story problem. Alright? So now we have the same kind of setup as above, but now we have an x squared and an 8x and a y squared and then minus 4y. So nothing new here. We just have to do the completing the square process twice. So during the notes on Wednesday, we should have discussed, if you really don't like the completing the square process, you do have that formula for how to find h and k. So you just have to have that memorized, of how to find what should go inside the parentheses with the x or inside the parentheses with the y, and what should go outside the parentheses. Here it's going to be difficult because it's not just x's and it's not just y's. Here we don't know if that 11 which it belongs to, so we won't be able to use the c here. We can still find the h term inside the parentheses with x and y, but getting that term that would be on the outside is going to be pretty difficult. So if you want to figure it out on your own, you can try to figure out a way to do a formula, but I'm not too sure how that's going to look like. And I won't be able to give you that setup. but we can try to keep doing some more completing the square problems so that way you can get the hang of it. So just like above, I'm going to group my x's together. So we have x squared plus 8x. I'm just going to do it all together and then move on to the y's, and then we'll deal with the 11. So we have x squared plus 8x. So what I need to do is take half of 8, which is 4, and then square it. So I need to plus 16 and then minus 16. And then when this turns into the parenthesis, how does that keep happening? I get x and then half of b, which is plus 4. Squared. And then minus 16. Alright, for the y's, same process. Write them all together. So I get y squared minus 4y. I would take half of my new b, so half of negative 4 is positive, is negative 2. Square negative 2, I get positive 4. And then if I add, I also subtract the same number, so I get y squared minus 4y plus 4 minus 4. A lot of 4's here, but when we push when we write it in the square form, we get y minus 2 squared minus 4. And now we can kind of add all of our pieces together. So we have the x parts, the y parts, and this plus 11 all the way down here. And that would all equal 0. So when we try to write this by combining that negative 16, the negative 4, and the 11, we would get negative 20 plus 11, so negative 9, and then that would scoot over to the other side by adding it to both sides. So our final equation would be x plus 4 quantity squared plus y minus 2 quantity squared equals 9. So our center will be at negative 4 because things flip-flop if they're coming outside of the parentheses, positive 2, and then our radius is going to be 9. Doesn't look like we have a graph that could fit this. We'll try to do it on the bottom one and just probably just stop drawing it once it gets too far off. So we go to negative 4, positive 2, that's where the center of the blue circle will be. And then I do the process of where starting at the center, we go 9 units in all directions. So starting at the center, if I count 9 to the right, I would get to positive 5. If I count 9 up, I will get to 11, which is off the graph, but it would be about right here. If I count 9 down, I would get to negative 7, which is on the graph, and that would be right here. And that, if I count 9 to the left from the center, I would get negative 13, which is definitely off. So let's just try to connect to our best ability. Hopefully your ability is more than mine. And then we can maybe just kind of finish it, right? So our blue circle is definitely huge. It's bigger than our red and our green. We can see where the center is because I'm color coding it. If you do have some questions on this, you can definitely do some YouTube searches for graphing circles from equation or completing the square for circles and everything like that. A lot of stuff should pop up. If all else fails, email me. I'm sitting in DC right now, and I can respond because I'm probably just waiting for something to happen for a debate or on my way to the place because it is still kind of early. So email me if you have any questions. Let's continue on a note. So now we have the story problem. The plan for a park puts the center of a circular pond of radius 0.6 mile at 2.5 meters east and 3.8 miles south. Do I keep going back and forth meters and miles? I'm sorry if I did. Of the park headquarters. Write an equation to represent the border of the pond using the headquarters as the origin. So what this is basically just giving us information. It gave us radius pretty clearly. But then it gives us these directions based on the headquarters versus the pond. So we can kind of think about this as directions, like walk 5 paces north, 2 paces east, and this is exactly what the coordinate points give us. And it's talking about the center. So this one should have been pretty straightforward, not too many wonderings here. Besides just what do we do with this? So remember, if we are east, that is in the x direction, positive, right? We have north, east, south, west. So their center would be at positive 2.5. And then south is be negative in the vertical direction, so that'd be negative 3.8. So now that we have our information, we can put this together into the equation. So there's no y equals, we actually do have to plug everything in. So we do x minus h, and here we have h and k. If that helps, we can label it like that. So we can do x minus 2.5 squared plus, there's always a plus when we come to circles in between the parentheses, y, and then we would do minus negative 3.8, which would turn into a positive 3.8. And then we need to set this equal to our radius squared. So let's do that over here. So 0.6 times 0.6 would be 0.36. Very strange. When we square a number smaller than 1, it actually gets smaller. So then here would be our final answer. Here's the equation for the pond's border, which is that perfect circle. So for number 3, write an equation for the circle if the endpoints of the diameter are blank and blank. This one's a little bit more tricky, and it's using some of the information that we reviewed on Tuesday after the quiz. So if we draw a circle and its diameter, doesn't have to be perfectly horizontal or vertical, what we should know is that our diameter is 2 times as long as our radius and actually goes right through the center. Another way to think about that is that the center is the midpoint of our diameter. So if we wanted to figure out where the center is, we would have to find the midpoint of these two numbers. So remember, midpoint is the average of the x terms and the average of the y terms. So we would do 2 plus 2 over 2. So that would be 4 over 2, which would be 2. Again, midpoint, 2 plus 2 over 2, which would be equal to 4 over 2, which is 2. Next, we would do 8 plus negative 2 over 2, which we would get 6 over 2, which means we would get 3. So that would be our center of the circle, which would then tell us how to plug in for h and k. We would then actually have to find the distance between the center and one of the points it gave us up here. So distance is equal to the square root of, doesn't matter which order, we just need to choose one of these. Let's just choose 2 and 8 because they're both positive, and then the center, which is 2 and 3. So we could do, ooh, that's nice, 2 minus 2 squared, and then for distance we subtract inside but add in between the parentheses. And then if we did the 2 up here minus the 2 from the center, then we can do 8 minus 3 squared, which means we get the square root of 0 squared plus 5 squared, which means we get the square root of 25, which means our distance, which is also our radius, would be just 5. So again, we were given these two endpoints. We found the midpoint because that's the center, and then we found the distance between the center and the endpoint in order to find the radius. So now that we have that, we can plug everything in, and sorry for trying to squeeze it in, but we would do x minus 2 because that's h, squared plus y minus 3 squared equals 25. Alright, so that's how we could graph a circle from an equation, and how we can write an equation from a story problem and just from a description. So we have all these other examples on the next page, which all looks really similar. So if we take a look at it real quick, and I think we might save this to review when I get back on Monday. 1, 2, 3, and 4, I just give you the center and the radius. Number 5, I give you the endpoints just like in the notes. 6, I give you the center and then just another point, and you can find the radius with that. And then we aren't going to worry about 7. So let's not worry about that. But what that does mean, tangent, that just means the circle, or tangent means touch. Secant means slice. So because it's tangent to the x-axis, we would be able to figure out the radiuses there. So if we keep looking through these example problems, I'm trying to do this for you so that way you can do a similar thing on the worksheet the sub will pass out to you once you're done with the video. And then also, if you did have a question, you can say, I'm stuck on the problem like number 9 on the note paper, and then I could try to walk you through it. So 8, 9, 10, 11, 12, and 13 are all set up, so you have to do the complete the square process, and once you do that, then you'll be able to graph your circle pretty quickly. And hopefully they have this set up so that way you can graph it still right on the graph, but be careful. Notice how there's no labels on most of them, so you might have to be careful and set up your axes to make sure that your circle fits. Alright. And then the last problem, we have a story problem, which you won't have on your sub work, but we can review all these when I get back on Monday. So good luck on your worksheet today. Hopefully this video wasn't too long. Please let me know if you have any questions, but hopefully the worksheet will be straightforward because it's just like the examples we went over, and it looks pretty close to this worksheet that's in your notes. Alright, see you on Monday.